Good afternoon, pilot teachers, and good afternoon, students.
Good afternoon, Ms. President.
Thank you. Sit down. Okay, what I'd like us to look at for our lesson today is we're going to start off with a correction of those activities that you were supposed to have completed. You had a passage. You're supposed to put in the appropriate word in the spaces that were left blank from that passage. So we will start off our lesson with the correction of that activity. And then we will move on to looking at two important words which come in with the movement on revolution. And the two words are solstices and equinox. So that's what we are going to actually define for our objective today. We'll start off with the correction of the activities which I ask you to complete for your homework. Okay, the answers, I'll go through the passage. The answers you will see on the monitor are in the color red, and you can also make corrections using a red pen, please. The words, list of words, the missing words that you are supposed to select from so that you will put into those spaces which are left blank. Note, south, sets, 6, winter, tilted, colder, revolves, excess, north, and sun. Okay, the passage. The sun revolves. That's the word that should go there, around the sun once a year. Oh, sorry, I'll repeat that statement. The earth revolves around the sun once a year. Okay, not the sun, the earth. The word revolves to go in that space. It also spins on its axis once a day. In July, the North Pole is tilted. That's the word that should go in that blank space, towards the sun. Therefore, places which are north, the word north was what was missing. So places north of the equator, they get more than 12 hours of daylight and less than 12 hours of night. Near to the North Pole or near the North Pole, in July, the sun never sets. The word sets should go in that particular blank space. Okay, we continue. 6 is the next word. 6 months later, the position is the other way around. The earth has traveled halfway around the sun. The South Pole is tilted towards the sun, and it is winter in the northern hemisphere, where short days and long nights make the earth's surface colder. Okay, so all of those missing words, they appear in the red color writing, and you can double check to make corrections to those activities you were supposed to have completed. Any questions or any queries with regards to that activity? Are we all happy with the answers given? Yes? Okay, good. Then we'll move on. As I've stated at the beginning, the objective for our lesson today is to see if we can discuss and explain the two terms associated with movement, the apparent movement of the sun or the revolution of the earth around the sun. And the two words are equinox and solstices. So by the end of the lesson, you should be able to define and know the definition to those two words. Okay, we're looking at the movement of the earth revolving around the sun. As explained earlier on, that the earth revolves every 365.25 days around the sun. The path that the earth, or the orbital path of the earth around the sun, also contributes to two very important effects. And those two effects are, one, the seasons, especially noted in the temperate regions of the world, and two, the varying length of day and night. Okay, looking at the explanation on the varying length of day and night, and the seasons. I had a chart in our last lesson, and I'd like us to look at the chart again so that we can recap on what we have covered. The title of this chart here is to do with the apparent movement of the sun. We know already that the sun does not move. It is the Earth and all the other planets which orbit or revolve around the sun. June the 21st, the sun is at its furthest point in the northern hemisphere, and it is directly overhead at the Tropic of Cancer. Therefore, in the northern hemisphere, the season which is experienced is summer. This is the time also that the areas in the northern hemisphere experience longer days and also shorter nights. It will take 3 months for the sun to be directly above the equator. It is now September the 22nd. The sun is directly above the equator. When the sun is directly above the equator, this is the time when there is 12 hours of day and 12 hours of night in both the northern and the southern hemisphere. Meanwhile, if we are following the seasons in the northern hemisphere, if it was June the 21st and we say it was summer in the northern hemisphere, when the sun is directly above the equator at September the 22nd, the season in the northern hemisphere then will be autumn. So the seasons, as you can see written on the chart now, are referring to the seasons in the northern hemisphere when we are following this example. Okay, so we are at the equator, September the 22nd, equal amount of day and night in the north and the south. The northern hemisphere, the southern hemisphere. 12 hours of day, 12 hours of night. Meanwhile, if we are looking at the season in the northern hemisphere, autumn follows summer. So in the northern hemisphere, it is autumn. 3 months later, the sun is at its furthest point in the southern hemisphere, and it is at 23.5 degrees, which is the Tropic of Capricorn. It is December the 22nd. In the southern hemisphere, if the sun is directly above 23.5 degrees in the southern hemisphere, it is now summer. It is summer in the southern hemisphere. Meanwhile, the season in the northern hemisphere will be winter. You remember I stated that the seasons here are to do with the seasons in the northern hemisphere. So we are now in the southern hemisphere. The sun is directly overhead, 23.5 degrees. It is December the 22nd. In the southern hemisphere, because the sun is here, the season in the southern hemisphere will be summer. But in the northern hemisphere, the season that follows autumn will be winter in the north. Okay, it will take 3 months again until the sun is directly overhead the equator again. It is now March the 21st when the sun is directly above the equator. The season in the northern hemisphere that follows winter will be spring. It is now spring in the northern hemisphere, and it is March the 21st. It will take 3 months before we come back to the furthest point in the north, and that is 23.5 degrees, the Tropic of Cancer. And it is now June the 21st again. The season that follows spring in the northern hemisphere now will be summer. And then the cycle continues. So when we are going from here to here, we have 3 months. Another 3, another 3, another 3. By the time we complete that revolution, it now will take 365.25 days. So basically what we have done here, we have looked at 2 things. We have looked at the varying length of day and night in each of the hemisphere, and also at those 3 important points when the sun is actually directly above them or away from them. And we have also looked at the seasons which are experienced mainly in the northern hemisphere and the southern hemisphere when the sun is at those 3 different points. If I had to look at the seasons for the southern hemisphere, okay, the example that I put up here were mainly the northern hemisphere seasons and the stages or the changes they go through when going through this explanation. What happens if we decided to start here and we decide that we are going to look at the seasons for the southern hemisphere and not the northern hemisphere? Okay, the sun is directly overhead 23.5 degrees to the south. What season will it be for the areas in the southern hemisphere? It is summer. So here we put summer. 3 months later, the sun is directly overhead the equator, March the 21st. What season is it for the southern hemisphere? Autumn, because the season autumn follows summer. 3 months later, the sun is furthest away from the 23.5 south, and it is now 23.5 to the north. June the 21st, what season is it in the southern hemisphere? Winter. It is winter, because autumn is followed by winter. 3 months later, the sun is directly overhead the equator. What season is it for the southern hemisphere? It is spring, because spring follows after winter. And then we come back to the southern hemisphere again. The sun directly above 23.5, and what season will it be in the southern hemisphere? Summer. Okay? We understand that? Any questions? No questions? Okay, we move on. The second chart. The second chart is another way of showing the same information. Remember, I made a statement in the last lesson that this is one way in which you can show that revolution of the earth around the sun, or what we call the apparent movement of the sun. Another way in which we can show the same information is by using a diagram like what I have here. Okay, you can title the diagram the apparent movement of the sun, or you can title it the Earth's revolution around the sun. We have the sun in the center here. We have the position of the Earth in the 4 different times: June, September, December, and March. Okay, it doesn't matter where I start. I could start here with September, I could start here with December, but the information will be still the same and showing the same information. I have decided that at the top here, I will put the month March the 21st. Okay, so we have March the 21st. Note the equator. The equator is directly, or the sun is shining directly above the equator at March the 21st. Therefore, 12 hours of day in the northern hemisphere, 12 hours of night in the southern hemisphere. The seasons experience spring or autumn, depending on whether we are in the north or south. The blue arrow, 3 months later, see the position of the earth now. The north pole is closer to the sun, or it's facing the sun. The south pole is actually away from the sun. So the shaded area here will show us winter in the southern hemisphere, summer in the northern hemisphere, June the 21st. 3 months later, the sun shining directly above the equator. Equal amount of day and night in the north and in the south. 3 months later, the south pole now is actually facing the sun. The north pole is away from the sun. Winter in the northern hemisphere, summer in the southern hemisphere. 3 months later, we are back to where we started from. So this is another way of showing the same information. Varying length of day and night, 12 hours of day, 12 hours of night in these 2 positions here. In these 2 positions here, we have longer days or longer nights, depending on which hemisphere is facing the sun or closest to the sun and which one is away from the sun. The hemisphere away from the sun will experience longer nights. Those closer to the sun will experience longer days. Any questions? No questions? Okay, we must also remember that one of the important facts that we have learned so far, beside looking at the important lines of latitude, and also beside the fact that the Earth does two important movements of rotation and also revolving, we must also note that the Earth is actually tilted on its axis. And the tilt of the Earth has a very big impact or influence on the seasons. You note this diagram here, it is showing that tilt. So the Earth is actually not straight up, straight down, where the seasons are the same right throughout. At certain times of the year, the North Pole or the South Pole is either tilted towards the sun or away from the sun, while the Earth is on its orbital path around the sun. And that is what also contributes to the seasons and the varying length of day and night. That information, as presented on the monitor, is similar to what I have put here. And it is basically showing us the apparent movement of the sun or the revolving effect of the Earth around the sun. So now we come to those two words of solstices and equinox. Where do they come in? These two words are important because when we are looking at the time of the year when the sun is directly above the equator, and it is 2 times of the year that the sun is directly above the equator. Christopher, what are those 2 times or the 2 months of the year when the sun is directly above the equator?
March and September.
Okay, good. March and September as shown here. Or as shown here, March and September. Those are the 2 times of the year that the sun is directly above the equator. Those are the times that we refer to as the equinoxes. The equinox basically talks about the time of the year when the sun is directly above the equator, relating to 2 times of the year when the sun is directly above the equator, and also that is the time when the Earth or the hemispheres have equal amount of days and nights. 12 hours of day, 12 hours of night, giving us the spring and the winter equinox. The 2 seasons that occur during the equinox are the spring and autumn. So spring and autumn are equinoxes. This is the time of the year when the sun is directly above the equator, and this is the time of the year also when we have equal amount of day and night in both hemispheres. 12 hours of day, 12 hours of night. That's what we mean when we talk about equinox. Solstices. Solstices, if we look at our chart or diagram, that is the time when the sun is directly above the tropics. The Tropic of Capricorn, Tropic of Cancer. When the sun is directly above the tropics, we use the term solstices to describe that time, and solstices also involves the seasons winter and summer. So we have the winter and the summer solstices. This is the time when the sun is directly above the tropics. The tropics. We have the Tropic of Capricorn in the south and the Tropic of Cancer. Winter and summer are the seasons that are experienced. This is also the time when we have the longest day or the longest night, and the shortest day or the shortest night, depending on where the sun is actually directly above. Okay, so looking at the definitions now to those 2 words, and perhaps you might want to make note also of those definitions. Equinox, first of all, from the information on the monitor, one of the 2 periods during the year when the sun's apparent path intersects the plane of the Earth's equator. Thus, the sun is directly overhead at noon on the 21st of March, which is the vernal or the spring equinox, and on 22nd of September, which is the autumnal equinox. And the simplest way to actually understand that information is that the time of the year when the sun is directly above the equator. And the seasons are spring and autumn in the northern hemisphere or the southern hemisphere. And it is also the time when right throughout the earth it is equal amount, or the earth has equal amount of day and equal amount of night. Not amount, sorry, equal hours of day and equal hours of night. 12 hours of daylight, 12 hours of night. Okay, do we have that information? Okay, that's not all. In addition to the definition given on the monitor, we also have the term equinox is actually derived from equal night, because at this time the lengths of day and night are approximately equal throughout the world. So you can also include that bit to the definition on equinox. Okay, we move on to looking at the definition for solstices. Remember, I mentioned also that solstices is the time of the year when the sun is directly above the tropics. We look at the winter and the summer seasons coming in together with solstices. And it is also the time of the year where we have the longest days, longest days and shorter nights, or vice versa, in the different hemisphere. From the monitor, the definition given there, it reads the time during winter or summer when the overhead midday sun reaches its maximum or minimum declination or angular distance from the equator. The summer solstices of the northern hemisphere is about June the 21st, when the midday sun is vertically overhead at the Tropic of Cancer, which is 23 degrees and 27 minutes to the north. I'll give you time to make note of that information, and there's a little bit more to go with that definition. Maybe to explain just a little bit more on that first statement on the time during winter or summer when the overhead midday sun reaches its minimum or maximum declination or angular distance from the equator. In other words, we are looking at when the sun is actually above this point here. That means it is at its maximum. And if we are looking at this point and we are making reference to the overhead sun in the southern hemisphere, then that point will be at the minimum distance from the sun's rays or angles reaching it. And that's what we mean by that statement, minimum and maximum. If you are in the northern hemisphere and the sun is directly overhead 23.5 degrees, it is at its maximum point. Meanwhile, in the southern hemisphere, it is at the minimum point away from the angle of the sun. And that's what we mean with that statement. Okay, we move on. The winter solstices for the northern hemisphere is about December the 22nd. And when the midday sun is vertically overhead the Tropic of Capricorn, which is at 23 degrees and 27 minutes to the south. In other words, when the sun is 23 degrees and 27 minutes to the south, then it will be winter in the northern hemisphere. Okay, we've made note of that information. Okay, good. Okay, that's not all. Finally, the summer solstices has the longest day, while the winter solstices has the shortest day. And that's the last bit of information that will go together with the information on equinox and solstices. Okay, so having copied down the definition to equinox and solstices, Ebony, in your own words now, can you explain in your own words what you understand by the term equinox?
The
equinox is 2 periods during the year when the sun is directly above the equator.
Okay, more information. That is definitely correct. More information.
The climate that takes place in either the southern or northern hemisphere is spring or autumn.
More information.
And there is an equal amount of hours of day and night
In both hemispheres.
in
Okay,
both hemispheres.
very good. Not the climate in the north or the south, but the seasons that are experienced in the northern hemisphere or the southern hemisphere are those of autumn and spring. So the three important information that you must have with your definition, number one, the time of the year when the sun is directly above the equator. Number two, the seasons that are experienced in the northern and the southern hemisphere are mainly autumn and spring. And number three, this is also the time when there is equal hours of day and equal hours of night in both hemisphere or right throughout the world. 12 hours of day, 12 hours of night. Very good. Catherine, what do you understand by the term solstices, or explain in your own words the term solstices?
Two periods of the year that when the sun is directly above the tropics. There are two seasons involved, winter and summer. They experience longer days and shorter nights.
Okay, good. But bearing in mind, you must know which hemisphere experiences the longer days and which hemisphere experiences the shorter nights, and vice versa. Because for you to be able to note the position of the sun, you should be able to work out which hemisphere will have the longest days, which one will have the shorter nights, and vice versa. Okay, finally, to finish off the work that we have covered now on equinox and solstices, I have a chart here of which it might be of interest to you. And looking at the chart, we note the words or the numbers written in red, they represent the different latitudes. And when we've looked at the important lines of latitude, we're looking at lines like equator, the Tropic of Capricorn, the Tropic of Cancer, the Arctic Circle, Antarctic Circle, the North Pole, and the South Pole. But here are some selected lines of latitude. 0 at the equator, 17 degrees, 41 degrees, 49 degrees, 63 degrees, 66.5 degrees, which is the Arctic Circle or the Antarctic Circle, if I had to put the direction here. 67 degrees and 21 minutes, 69 degrees and 51 minutes, 78 degrees and 11 minutes, 90 degrees. 90 degrees is the highest line of latitude. There is no such thing as 91 degrees because the furthest point to the north or to the south is 90 degrees. Okay, looking at those selected lines of latitude, we have the length of longest day, hence also of the longest night at those different latitudes that I have listed here in red. At the equator, 0 degrees, 12 hours of day, 12 hours of night. 17 degrees, you can have 13 hours of daylight. As you go 41 degrees, 15 hours of daylight. 49 degrees, 16 hours of daylight. 63 degrees, we go 20 hours of daylight. 20 hours of daylight, how many hours of night? Just 4. We come 66.5 degrees, 24 hours of daylight. These people always will see the sun, 24 hours. We come 67 degrees and 21 minutes, 1 month. 1 month, they see the sun. 69 degrees and 51 minutes, 2 months. 78 degrees and 11 minutes, 4 months. And finally, 90 degrees, you can have 6 months of daylight or 6 months of darkness. Maybe that's extra information just for interest. And if you do have some questions about or around this, you can feel free to ask. Any questions on that? Aren't you lucky to be at the equator where you have always 12 hours of day and 12 hours of night? Imagine if you were at the North Pole or the South Pole. You might have 6 months of daylight and then 6 months of night. Any questions? Okay, maybe you might want to think about this, and some of you might have some questions to ask in our lesson or in our next lesson. That will also bring us to the end of our lesson. We have looked at equinox and solstices, and bearing in mind when we're dealing with the revolution of the earth around the sun, those two words are important because they have to do with the varying lengths of day and night, and also they have to do with the seasons. Okay, class, if you could stand up now. To the pilot teachers, our keyword for lesson 87 is solstices. Good afternoon and thank you, students.